gosh, didn't see there. Come on. Okay, so trust me, I tried everything that I could think of in order to screen record my screen, but it was not working. So I'm just gonna record it here. So have fun with that. Let's just read the question. So the following table is based on the functional relationship between x and y that is either an exponential or power function. And then we get this table of values right here. So use the appropriate logarithmic transformation and a graph to decide whether the table comes from a power function or an exponential function, and find the functional relationship between x and y. And then we have to find the relationships in terms of x and y. Whoa, look at that. I did not know you could write on this. Anyways, don't look at this. That's the answer. Oh my gosh. Okay, pretend that doesn't exist. Anyways, yeah. So the first thing you're gonna do, write out your table of values onto Excel. You can do it on Google Sheets or a calculator, but I prefer this because it's better. So yeah. Now first thing you're gonna do is log your y values, because as we know, your an exponential function is simply a linear model on a semi-log plot, and a power function is a linear model on a log plot, right? So we're going to start with the semi-log because that's just easier, obviously. So now we take this and, oh my gosh, I don't have 20 hands. And we insert a scatter plot. Now this is pretty linear. Actually, yeah. So I don't even know if we have to log the x values, but we're just gonna do it because it's not that difficult. So yeah. And since it's that, I usually just like to put 0. I don't even know if that's right, but we just insert scatter plot. Okay, and this one is less strong, so we're definitely using this one, which is a semi-log plot, and that means that it is an exponential function. So then we just want to put the equation on the chart, and oh, I do not know why I did that. Yeah, so this is our equation, and now we're just going to write it down on our little piece of paper. Okay, so I'm not sure if you watched my last video, but it was very entertaining, so go ahead. But this one is different because our format now that we want to get to, because the one we currently have is a linear model, but we want to get to an exponential model. So yeah, our general equation for a exponential function is y equals cb to the power of x. Okay, and c and b are just constants. So that's what we're trying to find. And we know that this linear model is actually a semi-log. So what we're gonna do is make y into its log. So we do log y equals 0.301x plus 1.0792. So I don't even know, can you see that? Okay, all that we did was take our little y and put a log in front of it. Okay, to keep it simple. And we're trying to transform it into this at the end, because currently we have a linear, which is y equals mx plus b. So yeah, we know, just to clarify, we know that 0.301 is our slope, and this number right here is our y-intercept, or in this case, our log y-intercept. Vertical axis intercept. Okay, so like in the last video, which you should go see, we have to get x on the same side as log y, because we need to simplify it. Okay, so what we're gonna do is log y minus, because we're taking it over, log 10 to the power of 0.301x equals 1.0792. because we need to log it, right? And if you use your log laws, for example, the y equals, why did I say y? That's not what I meant. Log a b equals c means that b equals a to the power of c. If you use this log law right here, then you realize that log 10 to the power of 0.301x is the log of 0.301x. So this is how our third line looks right here, and up here you can see this value. Right, so now we need to do something about this one. We need to log that one too, and that's going to be the same thing that we did with the other one. So our next line will be log y over 10 to the power of 0.301x equals 10 to the power of 1.0792, because that's the log. So here's our fourth line right here. We combined these two, and since they're being subtracted from one another, we have to divide them. Yeah. So now we can take this x function right here, and we cross the log out because we have just logged this side, right? So I hope you understand that. I don't know, but you combine the logs and then you take the log away and you log this side. Yeah, so you're just left with this little division over here, and if you know your math laws, then you know that you can multiply this bottom value by here to get them together. So in the end, you will have y equals 10 to the power of 0.301x times 10 to the power of 1.0792. And that's that. And now we have it in the form of y equals cb to the power of x. Yay! So let's pray that's the right one. Let me check the answer that I got, because you never know these days, am I right? Yes! Let's all cheer. Make sure that both of our... we're not doing this.